All right, let's pull back the curtain on what's really going on behind pretty much every piece of software you use. We're talking about the architect's blueprint, data structures, and algorithms. This is the fundamental stuff, the real nuts and bolts that let developers build the powerful, efficient apps we all depend on every single day. So, have you ever stopped to think about this? How does your music app find that one specific song you're looking for out of literally millions of options, and it does it in the blink of an eye? Well, spoiler alert, it's not magic. It's actually a really elegant solution to a massive information problem, and that's exactly what we're going to break down right now. So let's dive right into the core problem every single developer has to solve. We can just call it the information challenge. At the end of the day, almost all modern software is really about one thing: how to handle an unbelievable amount of information and do it as fast as humanly or, computationally possible. And this right here, this is the central problem. I mean, think about it. Your social media feed, a quick Google search, even a simple transaction at your bank. If you get the organization and the processing wrong, you end up with slow, buggy, and super frustrating software. But if you get it right, everything feels snappy, seamless, and just instant.
So how do we get it right? Well, if we're thinking like architects, the first thing we need to do is understand our building materials. And in the world of software, those materials are what we call data structures. Now, here's the key idea you have to get. A data structure isn't just some generic container for your data. It's a specialized format built for a reason. Think of it like this. A bookshelf is a great structure for organizing books you want to browse through. But a dictionary? That's a way better structure if your only goal is to find a word's definition as fast as possible. The structure is always designed for the task at hand. And here it is. This is basically the programmer's entire toolbox. Over on the left, you've got the basic types that are kind of built into most programming languages, things like numbers and characters. But the real power, the magic, comes from the right side, the structures that developers build themselves, like lists and trees and graphs. These are the heavy lifters that solve the really complex problems. So let's look at some of the most common tools in that box. You've got arrays, which are kind of like numbered shelves, perfect for when you have an ordered list of things. Then you have lists themselves, which can act like a stack of plates. The last one you put on is the first one you take off. Trees are amazing for anything with a hierarchy, like a family tree or the file system on your computer. Graphs are all about connecting things, like how your friends are connected on a social network. And then there are hash tables, which are like a magic index, letting you look things up almost instantly. Every single one is designed for a different kind of job.
Okay, so now we have our materials. We've got our data structures, but a pile of bricks doesn't just become a house, right? You need a plan. You need a blueprint. In our world, that plan is called an algorithm.
This is the logical next question, isn't it? I mean, having perfectly organized data is great, but it's totally useless if you don't have a systematic way to do something with it. Like, I don't know, finding that one song you want to listen to. And the answer to that is an algorithm. Really, that's just a fancy word for a recipe. It's a very precise, step-by-step set of instructions that tells the computer exactly what to do with the data we've so carefully organized. Let's look at a super simple example just to make this crystal clear. It's called a linear search. You literally just start at the very beginning of a list, you check the first item, then the second, then the third, one by one, until you find what you're looking for. It's really basic, maybe not the fastest, but it's a perfect illustration of a clear, step-by-step procedure. Okay, so that linear search is simple, for sure. But is it the best plan if you're searching a music library with millions of songs? Oh, absolutely not. And this brings us to what might be the most critical skill of any software architect: choosing the right tools for the job by analyzing how they perform. This is where the real engineering kicks in. See, it's not enough to just solve a problem. You have to solve it efficiently. And performance analysis is how we measure our solutions. We ask those critical questions like, how much time is this really going to take? And how much memory is this going to eat up? The answers to those questions are what make an app feel fast and responsive or frustratingly slow. This table right here illustrates the trade-offs perfectly. Just look at an array versus what's called a linked list. An array is lightning fast if you need to grab an item and you already know its position. But trying to insert a new item into the middle, oof, that's painfully slow. A linked list is the complete opposite. And that's the core of performance analysis. There is no single best tool. There's only the right tool for the specific job you're trying to do. So let's bring this all home. Why is it so incredibly important to master this blueprint? Because this is how you go from just, writing code that works to actually engineering powerful, elegant solutions.
When you master these concepts, you gain this incredible set of skills. You're no longer just writing code. You can implement multiple solutions to a single problem. You can intelligently explain why you chose one tool over another. And maybe most importantly, you can actually prove with hard data just how efficient your solution really is.
And at the end of the day, that's why this all matters so much. This quote from a university course pretty much sums it up perfectly. This isn't just abstract theory. These are the fundamental, practical skills that every single employer in the tech industry is looking for.
So, there you have it. We've laid out the architect's materials and the construction plans. You now understand the blueprint that powers pretty much every piece of modern software. So the only real question left is, with this blueprint in your hands, what are you going to build?